Okay, so let's continue our demonstration here for Haproxy. So again, this is a LoongArch mini PC, and which has a Wi-Fi access point, and then the TV right now is playing music that has connected to the Wi-Fi access point. So this guy, LoongArch mini PC, is providing the streaming, the internet services for that TV, right? So that's the egress traffic. So now we want to talk about the Haproxy, which is ingress traffic. So which is we can say we want to send traffic from internet to the to this mini LoongArch firewall, and then this guy will do the load balancing by Haproxy to internal server, which happen to run the Intel version of x86 version of open source firewall BP Fire. And so this is our LoongArch mini PC Longfire open source firewall web UI. Okay, so yeah. So, but first, let's look at this Haproxy website. It talks about this feature, this DDoS protection feature offered by the Haproxy in the paid version. So this is not the free version, okay? So the Haproxy called the Packet Shield, a tool for superior DDoS protection. And so the underlying technology they are using is the initially they used the, let's see the conclusion here, a lot of the conclusion. So the first, they used the, by the way, this is a diagram how the DDoS SIM cookie protection works. And yeah, that's the diagram. And so the technology Haproxy is using for the paid version is, yeah, so first they use the net map. Yeah, so the first they use the net map, and then they're switching to the called NDIV, which is their internal design. So they used the XDP framework. Okay. So yeah, so this is a paid version. But what I'm going to demonstrate today is let's use the open source version of XDP DDoS that we actually has talked about in our previous video. And so let's go to the demo here. Okay. So this is our Longfire web UI. By the way, you can change the languages. So let's go change to the English. Save. And so here we will use this XDP DDoS protection, which is open source version. Okay. So first, let's test the Haproxy load balancing without DDoS protection. So I will use this machine as a test machine. So here, this is another web UI for firewall. So which is the backend. Let me just do a refresh. Okay, so it is working properly now. Let's go to home. See this guy, it has an IP address 192.168.9.14. Okay, so that's the backend BP Fire open source firewall, which is this guy, and then this LoongFire did the load balancing by Haproxy to this BP Fire open source firewall, which is the web UI we're looking right now. So notice the difference, BP Fire, and the IP address 192.168.9.14. So the load balancing right now is working properly, and we can go back to this LoongFire, the front end firewall, and we can double check the backend server here. So see this guy. So this is our backend BP Fire. Okay. So right now the load balancing is working properly. So this is a dynamic DHCP dynamic leases, the IP address. Okay. So see in the green network, we have 192.168 subnet for the internal green network. And so this is our 10.0.0 is our internet facing subnet, right? So we look at our Haproxy configuration. Excuse me. var IP fire. Oh, cannot see here. Okay. IP fire Haproxy. Let's look at our Haproxy configuration. And so here is our BP Fire backend server, right? Port 444 listening. And so this is our front end Haproxy listening port 8444. So when we send a request to the front end 10.0 here, port 8444, it actually load the balance to this BP Fire 9 with this green network backend address. Okay, so now let's turn on the DDoS protection from the web UI. This is what we do here. First, in the firewall rules, we have this firewall rule for port 8444. Let's edit the setting. So the destination is any. Here is the protocol TCP. So the listening port for the firewall to open is 8444, right? We want the firewall allow incoming connection to this listening port 8444, which is the Haproxy front end is listening on. So here is how we turn on the XDP DDoS protection. Let's turn it on and accept, right? Let's update the firewall rule and apply the changes, the firewall will change. Okay, and we can check the IP table rules here to make sure the DDoS protection IP table rule is set up properly. So the 8444 is a listening port. So see here we have the XDP SIM proxy for the destination port 8444. So this we have another XDP SIM proxy on the red 0 interface for destination port 8444. Okay, so this is the 2 IP table rule that is required for the XDP DDoS protection. So now we have the IP table rule set up properly. Now we also needed to go here, IP file, to actually load the XDP DDoS program. Okay, so we need to enable this to load the XDP TCP DDoS program. Also, we want a protection on port 8444. Then we save. Okay. Now let's use the command line to double check the PD loader status. So we have the XDP DDoS program that is always loaded, but we wanted to make sure the TCP DDoS program is loaded. So here we have the sync cookie XDP, that is the TCP DDoS program that is loaded. Okay, and it is a tail call of this XDP DDoS program. Okay, so we also have the map. We can show the map. That is will show how many sync cookie we generated. Map, dump, name, values. So right now it's 197. Let's watch this counter when we send the traffic. Let's anyone. So let's watch this counter, and then now 197, right? Okay, from this test machine. So right now, let's see our collection, the load balancing collection still works for the BP Fire backend. So you notice for the x86 based firewall, I have more XDP features. Actually, the LoongFire also has similar feature. I just not have added the menu here yet. But anyway, the load balancing is working properly, okay? Because I can browse this website, the backend web firewall works fine. And so now let's send SIM flag from the, let's log into another test machine. Let's use HP. Okay, so this is the LoongFire firewall IP address, internet facing IP address. This is a listening port, and we use a SIM flag, okay. So now let's look at the counter here, the LoongFire counter. Open source firewall shows the counter is increased by 1 second, right? So it is generate a sync cookie for this HP SIM flag. So it's not a real fast SIM flag, but this is just for testing purpose to send the SIM flag. And at the meantime, we can still browse this load balancing services. Works fine, right? Right? So the SIM flag does not affect the load balancing services. And at the meantime, the SIM flag packet is stopped, and we can activate this and run a TCP down. And we do not see packet we do not see packet from the TCP down, right? Because it's already blocked by the XDP DDoS program. But if I disable the XDP DDoS here, we will see the SYN flood. Or we will see the packet in the TCP down for the SYN flood. Right? So SYN packet, right? Right? So that's, and by the way, we can enable it again. Okay, and then the TCP down should be stopped. No more packet. Okay, and so all this is happening while our TV is playing, like for internet services, is not disrupted, right? And also for load balancing, ingress traffic is not interrupted. And we are also at the same time stopping the SYN flood attack. So yeah, let me search a map. Let me get a picture. I might have the picture here. Yeah, maybe next time. Okay.